let's very quickly talk about logistic regression. I'm going to go through the code first, and then after that, I'm going to explain what logistic regression means. For this one, I'm going to use breast cancer data set, and then that data set, you can find it in sklearn. So I import that, and then we need train test split because I think we mentioned this before, but the reason for that is we are using supervised learning. So when you're using supervised learning, you will train your data on a portion of your data set, and then you will keep another portion of your data set for test because you want to see how does your data set and how does your model if your model is able to predict the test. So the part of data set that is test is never going to be exposed to model. So model does not know anything about it. And it's purely going to guess the answer based on what it is trained on. So that is why it is important to split your train and test to make sure that a part of your data set it will remain unseen to your model. So, and then the next one is that we are supposed to, clearly we have to have logistic regression here. So we're going to import we're going to import logistic regression from sklearn linear model. And then, so very quickly, what logistic regression is when you're using binary or categorical type of classification. It is just yes or no. You can only respond with yes or no in logistic regression. So, for example, in this in this data set that we are using, is if somebody have breast cancer or doesn't have breast cancer. So that is why we're using logistic regression. Logistic regression, we gotta use accuracy score to see how it does. And we talked about accuracy score. Just because accuracy score is good, it doesn't mean that your model did well because accuracy score is just all of the correct answers over all of the answers. So if your data set is unbalanced, so for example, if you have um, only 5% of your data people have cancer, 95% doesn't have cancer. So the chances are you will encounter with many not cancer. So and your model is just gonna say not cancer to everything. And then when your model starts saying not no cancer to anything, your model is gonna be useless. Even though in this case, the accuracy score is going to be 95%, but you have an absolutely useless model. And then we are going to talk about confusion matrix. Um, in confusion matrix, I will show it to you how it works, but it is very easy to exactly see how many data were correct or incorrect. Let's go through it when we reach there. So keep that in mind. It is another way of measuring how well your model did. And then we have the classification report. Okay, so and again, don't mistake this with the clustering algorithm that we went through. Clustering is for unsupervised learning. Logistic regression is for supervised learning. The reason for that is logistic regression is the clustering algorithm in unsupervised learning. They don't have any label. They don't know what your data is about. They just know if they are similar to each other or not. But logistic regression already knows the answer and it tried to predict based on what the labels that it was trained on. It is trying to predict the answer. The difference, the way that I would explain the difference between them is cluster is like when we are using clustering algorithm in unsupervised learning. It's for example the scientists who are trying to do experiment to figure something out. But when we are talking about logistic regression, it's like for example the student in the class, the teacher already knows the answer and trains the students, and then they test them to see how well they understood. And then they test them on the data on the questions that they haven't seen before to see how well they're going to do. So logistic regression is supervised and clustering is unsupervised. Now we are using matplotlib and seaborn for visualization. And then let's start the code. First line of code is load the breast cancer data set. And your X is going to be data.data, and then your Y is going to be data.target. So this means that all of the features are going to be assigned to X, and then the labels are going to be in Y. So that basically means X is all the explanation and Y is the label for those explanations. And then the next step we do is we want to split the data set into training and testing, as we explained why we're doing this before. So you have X train, X test, Y train, Y test. The test size we use 0.3. That means 30% of your data is going to be saved for test, and then 70% of your data is going to be for train. And very clearly, you want more data to train your data set with, and then smaller size, but then it has to be reasonable. And then again, we're setting the random state. The reason for that is we want the code to be reproducible. Two different, when we are running it two different times, we're going to get two different answers. Not dramatically different, not, okay, I shouldn't say, not drastically different, but dramatically different. Not drastically different, but if you want it to be reproducible, it's just a good idea to have a random state. In the theory video that I'm gonna make, I will explain to you what does these concepts mean. Like what convergence. Well, okay, convergence means that you are reaching an optimal solution. That if and that means that at that point, it doesn't matter how many times you're going through your data, you're not gonna get any better result, or the difference or the results just get improved very minimal. So at that point, you're saying, okay, you reached a convergence. The model learned enough. And here, the maximum iteration, we are saying 5,000. We are saying that maximum iteration is going to be 5,000. So we're giving enough iteration to the model to converge. And then after in the concept class, I'm going to go in depth. What does this mean? And then we are going to train our model. We are using fit to train. So we're using X train and Y train. Clearly, we're not passing. As you can see, when we are training the model, we are not passing X test and Y test. The only X and Y, the data and the label that we are passing is our train portion of the data set. Then we are going to predict with our test set and see how well our model did. This is the line of code that makes the prediction. We're passing the X test. So we're not passing the Y test. We're not giving the answer. We're just passing the X test to see how well our model did. And then after that, we are going to calculate the accuracy. This is a metric that's going to measure how many correct answer you were able to get from your model. And I'm going to show you what confusion matrix is. It's actually very interesting, and it is a very good insight in your code. As soon as we run it, I'm going to point at confusion matrix and tell you what it is about. We have a classification report, and then after that, we are going to visualize the confusion matrix. And now let's run it. First of all, we are looking at accuracy. Our accuracy is 0.98. Okay, this is pretty good. And then we are looking at the confusion matrix. We are looking at the confusion matrix. It says 61 to 106. So what does this mean? Let's look at this visualization. This is our confusion matrix. When the actual benign is the same as the predicted benign, that means it predicted correctly. So this is the correct answer for benign. That means these were the cases that were actually benign. That means this is predicted, and here it is benign. This predicted, and in this column, you have predicted benign. So this color is benign, and this row is benign. Is the actual, this is predicted, okay? So that means since this is predicted and is predicted benign, and this is an actual benign, that means that it has predicted correctly. So these are the number of correct prediction. And then the number of benigns that were not predicted correctly are 2, because we are looking at predicted benign. So these are predicted benign, but they were actually malignant. These are the ones that were predicted that they have cancer, but they were actually benign. They didn't have cancer. Okay? And then we have 106 that were actually malignant and were predicted malignant.